It's been just a few years since the James Webb Telescope was launched, and for such a relatively short time, this powerful piece of equipment has already made plenty of discoveries. By observing the universe in infrared light, James Webb lets us see things no other telescope has ever shown before. And it's not just taking prettier pictures. It's giving us so much amazing data that scientists are having to rethink how everything from planets to black holes gets started. We're going to explore 3 of these huge discoveries. First, how Webb took what looks to be the first ever direct picture of a planet the size of Saturn. Then, we'll look at the strange black holes Webb is finding in the early universe that just shouldn't be there. And, finally, we'll peer inside the fiery clouds where stars are born, seeing them in a way that's been impossible until now. These are big changes to our understanding of the cosmos. Directly imaging a ghostly world for a long time, finding exoplanets was an indirect game. Astronomers would see a star's light dip just a little bit, or see the star wobble, and know a planet was orbiting it. These methods are brilliant, and they've helped us find thousands of planets. But actually seeing one of those planets is a totally different challenge. The star's light is so bright that it just washes out the faint light from the planet. But the James Webb Space Telescope was built for this kind of challenge, and it has given us compelling evidence of the direct imaging of an exoplanet with a mass similar to Saturn. If it's confirmed, it will be Webb's first direct image discovery of a planet. Meet jwst, a world orbiting a young star about 110 light-years from Earth. For the first time, we have something that isn't a graph or a shadowed S, what appears to be a real picture of a planet this size. So how did Webb do it? It used a special piece of equipment called which was developed by French scientists and is part of Webb's mid-infrared instrument, or mirror. It's basically a high-tech shield that is designed to block the blinding light from the host star. By blocking that glare, the very faint glow of the planet can finally be seen. After some advanced image processing, there it was. A faint, warm dot. And this discovery is a very big deal. This star, TWA7, is surrounded by rings of rock and dust, which are the materials for building planets. The object, TWA7b, is sitting right in a gap in one of those rings. Its brightness and location perfectly match what computer models predict for a Saturn-mass planet that is shaping the disk around it. We aren't just looking at a planet, we might be witnessing a planet forming right in front of us. Its gravity seems to be carving its own path in the disk, clearing a lane like a snowplow. This is groundbreaking because it opens up a whole new type of exoplanet for us to study directly. Before Webb, we were mostly limited to seeing huge, Jupiter-like planets. Worlds with the mass of our own Saturn were just too hard to see. Now, we can start to take pictures and analyze the atmospheres of these smaller worlds, which is a huge step toward understanding all the different kinds of solar systems out there. Bizarre black holes. At the center of most large galaxies, including our own Milky Way, there is a supermassive black hole. For years, the main theory was that they grew slowly. A big star would collapse, form a black hole, and then over billions of years, it would merge with other black holes and pull in gas to get bigger and bigger. But the James Webb Telescope is finding black holes in the early universe that are already enormous, much too big to have grown that slowly. It's like finding a skyscraper just a few years after bricks were invented. And Webb has uncovered 2 big clues that suggest black holes have a much faster and stranger origin story. The first clue comes from a strange system nicknamed the Infinity Galaxy, which formed from a collision of 2 galaxies. Using Webb, astronomers found not 2, but 3 supermassive black holes. 2 were at the centers of the original galaxies, but a third, with a mass of 1 million suns, was found in a huge cloud of gas between them. This has led astronomers to believe they are witnessing the birth of a super black hole through a process called direct collapse. The idea is that a massive, dense cloud of gas can collapse directly into a black hole, skipping the star phase entirely. The intense pressure from the galactic collision may have created the perfect conditions for this to happen. While this has been a theory for a while, the Infinity Galaxy provides some of the strongest evidence that it's real. As if that wasn't enough, Webb has also spotted the most distant black hole merger ever seen, in a system known as G7, just 740 million years after the Big Bang. Webb saw 2 galaxies crashing together, their central black holes spiraling toward a massive merger. Webb's incredible cameras allowed astronomers to actually see the 2 black holes separately as they came together. One of the black holes is already 50 million times the mass of the Sun, which is a giant for so early in the universe. These discoveries suggest that mergers are a very common way for black holes to grow quickly, even at the very beginning of the universe. and the possibility of direct collapse gives way for huge seed black holes to form almost instantly. Together, these findings are helping solve one of the biggest puzzles in cosmology. The rules for how black holes form are being written. We are living in an amazing time for astronomy, and these discoveries are just the beginning. If you want to stay on the front lines of what's happening, take a moment to subscribe and click the notification bell. You won't want to miss what comes next. Peering inside cosmic nurseries. Starbirth has always been hard to see because it happens inside huge, thick clouds of gas and dust, called nebulae. Telescopes that use visible light, like Hubble, can only really see the surfaces of these clouds. It was like trying to figure out what's happening in a house by only looking at the front door. But James Webb observes the universe in infrared light, and for Webb, these dust clouds are more like translucent curtains than solid walls. Its golden eye can see through the dust to reveal the stellar nurseries inside in amazing detail. We're no longer stuck outside, we've been invited in. For example, look at the new images of the Cat's Paw Nebula, which is about 4,000 light-years away. To celebrate its 3rd anniversary, astronomers pointed Webb at this massive star-forming region. The pictures are spectacular. Where other telescopes saw blurry blobs, Webb sees incredible structures, like cosmic toe beans, with clusters of new stars inside. We can see how massive young stars are carving out huge cavities in the gas and dust with their powerful radiation. The fiery red clumps show where the most massive stars are forming, still wrapped in their cocoons of dust. Then, Webb turned to a region called N79, in the Large Magellanic Cloud, a satellite galaxy of our Milky Way. N79 is a true star factory. Over the last 500,000 years, it has been producing stars at twice the rate of the more famous Tarantula Nebula. This region is especially interesting to astronomers because its chemical composition is very similar to what star-forming regions were like in the early universe. So by studying N79, we are essentially looking at how the first stars might have been born. Finally, in the Triangulum Galaxy, Webb looked into NGC 604, another giant stellar nursery. It revealed more than 200 massive, young stars, far more than we knew about before. The images show how stellar winds from these young stars are blowing bubbles in the surrounding gas, which in turn can trigger new waves of star formation. These aren't just pretty pictures. They are rich with data that is changing our understanding of how stars and planets form. We can see the whole process, from a cloud collapsing to new stars lighting up their. With every new image, Webb is giving us more clues about where we all came from. So, from seeing a planet being born, to finding new ways for black holes to grow so fast, to peering inside stellar nurseries for the first time, James Webb is changing our understanding of the universe. The data we're now getting doesn't quite match the old ideas. We are seeing with our own eyes evidence of a planet carving its orbit out of a disk of dust. We have found compelling evidence for black holes forming through violent, direct collapse and rapid mergers, which helps explain how they got so big, so fast in the early universe. And we have pierced the dust clouds of nebulae to see the beautiful, chaotic process of starbirth in a way we could only dream of before. Each of these discoveries represents a huge leap. It's clear we're in a golden age of astronomy, and Webb is just getting started. It will soon be used to analyze the atmospheres of Earth-sized exoplanets, looking for signs of life. It's mapping the earliest galaxies to understand how the universe first lit up. The universe, it turns out, is a very busy and strange place. The biggest discoveries are still to come.